everyone. In today's lesson, I'm going to talk about standard deviation and variance. So you'll be introduced to standard deviation in year 9, and you will build into deeper concepts as you move on all the way to year 12. So far in primary years, you have been looking at mean, median, mode, range, and then you might have looked at a little bit of interquartile range before this. But it's important to understand standard deviation because if you want to make more summary points of the data that you are observing or making some mathematical calculations, it have to make sense. So we'll look at some examples and understand why standard deviation has come into picture. It involves with more complex formula, but don't worry, if you're using a Casio FX calculators, it's much easier for you to make use of it. Okay, so let's begin. Standard deviation. The deviation is a measure of how spread out the numbers are. So basically, let's take a look at simple test scores in your classroom. Not everybody will have the same score. Not everybody have performed close enough to each other, like unless you are streamed and you're on all extension kids, maybe like same ability, then maybe. But usually you do have some spread of data, some low scores, some close to average scores, and some high performing scores, and then way too high performing scores. So data is usually spread out, right? And the symbol that we are going to use is sigma. This is a lowercase Greek letter. So because sometimes you may also have sigma, which is like this E kind of looking letter. But this is called the symbol for standard deviation. And this is what you need to look for when you are using your calculator. Now the formula is easy. It is the square root of the variance. So now what is variance? Variance is defined as the average of the squared differences from the mean. So that means, first of all, we need to understand what mean is. We move this up here. Okay, to calculate, we need to find the mean. You all know mean is the add all the numbers and divide by how many ever numbers they are, right? We have been doing that. Now, for each of the number scores, what you're going to do is you're going to subtract from the mean. Let's take a look at this example. Let's say you and your friends have measured the heights of your dogs in millimeters. So 600 millimeters, this is a scale. These are the different types of dogs. So from the shoulder length, that's what we are from, and from the ground to the shoulder of the dog, that's the height. So these are your data scores, the heights that you received after measuring. Now we are going to find mean, variance, and standard deviation. So understanding the variance and what is standard deviation, let's take a look. So we all know that mean is you add all the numbers and divide by how many ever they are. So that ended up as 394 millimeters. So the average dog's height in this group is around 394. But if you see, none of the dogs' shoulder falls under that. It's just an average of the group. And then we are going to look at, like, this green line is 394 millimeters, and then we are going to now look at how far away each dog's height is from that average. So this one is 206 millimeters above, this is 76 millimeters above, this is 36, this is below and way below. So to calculate the variance, we are going to do, so we subtracted from the average, right? That's the difference squared, and you are finding the average of it, and then that tells you the variance. And if you square root that variance, that is your standard deviation. That means what you're trying to do is it's the average amount of the numbers in that group, uh, understanding how far away they are from the actual mean. So if you know the mean, and you know the difference of each score, we have squared it, and then we are trying to find the average of that value. So that, and then finally apply the square root. So this is what a standard deviation is. So now we can generalize the statement. What is it? How is it useful? Now we can show that the heights are within one standard deviation of the mean. So using the standard deviation, we have standardized a way of knowing what normal is and what is the extra or extra large or extra small. So that helps us to come to certain conclusions, saying like even in the test scores, who has performed exceedingly good, who are way below, things like that. So that's why standardizing score data requires a standard deviation to talk in terms of how well they are from a certain standard point of view. All right. So we'll take a look at further applications of standard deviation and how um, more data analysis have been developed around this. Thanks again. Thanks for watching and being patient with me today while I'm recording this video. Hope this was helpful and understanding standard deviation. Next video, I'll talk about normal distribution and how we make use of z-scores and standard deviation and mean to come to data analysis of different scenarios. Thanks again. Thanks for watching.